Alright, now we move on to the histograms. We already learned the frequency distribution, right? Frequency table is a good tool for summarizing the data. But we gonna learn an even better tool. It's called a histogram. And the histogram is a graph. So if it's a graph, it's visually display the shape of the data. So it's more easier to interpret. So first we shall learn histogram is a graph consisting of bars of equal width. Okay, and in the histogram, the horizontal scale represents the classes of quantitative data values. Okay, and the vertical scale represents the frequency. So which means we should have a frequency table. Then we can use that frequency table to draw our histogram. And the heights of the bars corresponding to the frequency values. So this is an example of a histogram. This is just the same example of our frequency table. We still use the lunch service time from McDonald's. So remember when we check the horizontal scale, we have these numbers. Remember in the first section, I mentioned that these are our class boundaries. So we total have 5 bars, means we have 5 classes, but we need 6 boundaries to draw our 5 bars. So these values are again the boundaries. So, and the height of each bar just shows you how many values in this group. Okay, this is how we draw a histogram. We should use the frequency table. And on this page, we will talk about the important uses of a histogram. So first, we know if it's a graph, it's visually display the distribution of the data. We can see the shape. And we can also see the center of the data if we use the histogram, right? Of course, we can see the spread of the data. How is the spread of the data? It's wide, it's narrow, something like that. And we can also identify the outliers. We will talk about outliers later. So far, you only need to know outliers are just extreme values. Of course, we also mentioned the relative frequency table in last section, and we can also use the relative frequency table to draw the relative frequency histogram, but the shape will be exactly the same one. So we just use the relative frequency to replace the actual frequency, but the shape will not change. Okay. Of course, when we try to interpret a histogram, we will focus on several parts. So the center of the data, the variation, and the shape. And if there's outliers, sometimes we can also see the change by time. So it's just a general information we can learn from the histogram. And these are some examples of histogram. The first one, this one, the green one, is a bell-shaped curve. So maybe later we will use this kind of shape always all the time. okay, because it's a normal distribution. It's a bell-shaped curve. And the second one, red one, is called uniform distribution. Why it's called uniform? We can check the height of each bar. They are very similar. They are uniform, so this is called uniform distribution. And the blue one, we say this histogram skewed to the right, because we can find a long right tail. So we call this kind of shape skewed to the right. Similarly, the last one, it has a long left tail. We call it skewed to the left. Again, we check the green one. This one is a bell-shaped curve. So it is a normal distribution. Okay. So this one will be the most important shape we're gonna learn later. Bell-shaped curve. And this is just a definition of skewness. It's not symmetric. It extends more to one side. So if it's a long right tail, we call it skewed to the right or positive skew. If it has a long left tail, we call it skewed to the left, also called negatively skewed. So this is a long red tail, and this is a long left tail.